All right, class, number 3 is one of the big problems on the test here. And it's Mr. Charles used this data from test scores of his 20 kids to create the following plot. So we have a histogram right here. And you can see my exam grades. It looks like a lot of people made 90 to 100 on his. And it's going downward to the left. That tells me it is skewed left. So that is definitely skewed left. And so that's what I see on that, and I see a gap right here. Start noticing all the things that you see here. I see a gap right there. So that tells me what I need to know for that. And then I look and I see this graph right here, the box plot, and I see this graph right here, the summary statistics. It looks like this part got cut off, but it just kind of keeps going right here, and it doesn't have an outlier, so we don't really need to see that. So we need to use CUSS to fully describe this data right here that we're looking at. And the first thing I want to talk about is center. And for center, you want to use the median if the data is skewed. And you want to use the mean if the data is symmetric. You know, if it looks like this right here and it's symmetrical on both sides, you would use mean. But on this instance, this is skewed left. So for center, I'm going to use the median. And the median is 83. So when I write about it, I would say this: the center is 83 based on the median. So that would be what I would say about center. The U, the unusual features. So what you want to talk about here, any outliers seen on the box plot, and any gaps seen on the histogram. Those would be your unusual features. And so there is an outlier here at 31, outlier right there, and I see the outlier, and there is a gap between 40 and 50. So those are the two things I want to talk about for unusual: outliers and gaps. So let me go ahead and write that. For unusual, there's a gap between 40 and 50. There is an outlier at 31. So this number is unusually smaller than all the other ones. And there it is on the histogram. You can kind of see the outlier too. But you can't tell that it's an outlier for sure until you see it on the box plot. All right. The next one is shape. The next S is shape. And for shape, you just say what shape it is up here. If it's skewed left, skewed right, or symmetrical. This one was skewed left. Remember the little skier man would go down to the left. That is skewed left. And that's really all you have to say about the shape. It is skewed left. And then the spread. And the spread is going to be based on one of two things. The spread will be IQR if the data is skewed. So you'll use IQR if you have skewed data like this, because if data is skewed, it messes up the standard deviation, and you have to use IQR. And you're going to use standard deviation if the data is symmetric. So for this particular problem, we are going to use the IQR because the data is skewed. So I would say the spread is, and let's look at the IQR, 91 minus 71, Q3 minus Q1. So IQR equals Q3 minus Q1, which is 20. So I would say the spread is 20 based on the IQR, since this is a skewed graph. All right, so that is everything I need. I have my center, my unusual features, my shape, and my spread, and I have this problem completed.